All right, predicting precipitation. Complete the table below by deciding whether precipitate forms when aqueous solutions A and B are mixed. If a precipitate will form, enter its empirical formula in the last column. So in order to solve this topic, we need to pull up the solubility table for ionic compounds in water found in ALEKS in the data section. So here's the table here. And they want us to see if a precipitate is going to form when I mix each of these two solutions. And if it does, to provide the empirical formula of the precipitate. So let's do the first one. We have iron 2 sulfate. We should be able to provide the chemical formula of that substance. It would be Fe SO4. Sulfate is a polyatomic ion with a 2- charge, and we have iron 2, so 2+. So there's the chemical formula. Now this is a solution, so I'm going to write aqueous here. We also have sodium hydroxide. That would be NaOH. I have a solution of sodium hydroxide, so I need to indicate that it is a solution. Now, what we have to do to answer this question is predict our products. So how do I predict the products that I get when I mix these two solutions? Well, this is a double displacement reaction. It has various names: exchange reaction, double displacement. The idea is if I take the cation from my first substance and swap it with the anion on my other substance, I get one of my products. So we would make iron 2 hydroxide. And what else would we make? Well, let's take the cation from this substance and swap it with the anion from this substance. We would also make sodium sulfate. Now, we're not finished. We predicted the products by swapping cation and anion, but we also need to see which of these, if any, is a precipitate. So are they soluble in water or are they insoluble in water? We need to check. Let's check iron 2 hydroxide first. What's the cation? Iron 2+. Let's find it. Here it is. What is the anion? Hydroxide, OH-. Where's hydroxide? Here it is. So let's go across and down till we find the point of intersection, which is right here. Is this compound soluble in water? No, insoluble. So will we have a precipitate formed? Yes, we will. So let's finish our chemical equation. This is a precipitate. What about sodium sulfate? Let's find sodium sulfate in our solubility table. Our cation is sodium, Na. Here it is. Sulfate is our anion. Here's sulfate. So let's go across and down until we find sodium sulfate right there. It is soluble in water. So there I'm going to put NaQ. So this is our only precipitate, and its empirical formula would be FeOH2. What about the second one? Copper 2 chloride. So we have a solution of copper 2, Cu2 chloride, and I mix it with a solution of potassium sulfide. Notice I should be able to write the correct chemical formula given the name. Let's predict our products. Take this cation, combine it with that anion. That gives me copper 2 sulfide. And also take this cation, combine it with that anion. I get potassium chloride. Which one of these is insoluble? Well, let's go back to our table and let's erase what we've already done. If I go back to our table and take a look, let's find copper. Copper is right here. Let's find sulfide right here. So if I come across to the sulfide column and copper 2 plus row, I see that this is not soluble in water. It is a precipitate. What about potassium chloride? Potassium chloride, it is soluble in water. So there I would indicate that this remains dissolved. It does not come out of solution. So if I take a beaker of this and a beaker of this, two solutions, mix them together, I'll have precipitate that will appear. So I do have a precipitate, and its empirical formula is CuS. What about the next one? Potassium hydroxide. Well, I have KOH is its chemical formula. It's a solution. Reacting with a solution of ammonium nitrate, NH4NO3. It's a solution. Let's predict our products. Take this cation, swap it with that anion, I get potassium nitrate, and I get ammonium hydroxide. If we check our solubility, I know that all nitrates are soluble in water. We can verify that. Potassium nitrate, here it is. Potassium nitrate, soluble, and you can see here all of these compounds are soluble. So I put an aqueous here. It does not come out as a precipitate. What about ammonium hydroxide? Ammonium is here. The hydroxide cation is here. Anion is here. That is also soluble in water. So in this case, if I take a solution of this, mix it with a solution of this, I get nothing. No reaction, because this doesn't form, nor does this form. The water molecules keep them apart, keep them hydrated, so nothing new is formed in this reaction. And so here, does a precipitate form? No.